Hello students, a very warm welcome to JEE English, Unacademy, India's leading and largest test preparation platform. And guys, today we are going to get started with really something very interesting. We are going to deal with, like infinite kind of, structures, geometrical structures. And yes, that is going to be super interesting. And yes, this is going to be an extension of the last class. Even if you haven't understood last class, this class can help you do that. But anyway, make sure you are maintaining continuity in electrostatics and as well as practicing every day. And that being said, students, do not forget to like the video, do not forget to share the video, and do not forget to click on that bell notification so that you can get timely updates, and also click on that subscribe button. And that being said, guys, who know me well and good, if not, I'm Murlidharan Gopalakrishnan. I completed my MS in electrical engineering from one of the top ranking American university, and I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I've filed 25 patent applications in India, US and Canada. And guys, that being said, if you're not yet on a Telegram channel, do get onto a Telegram channel. I'll tell you why. And first of all, how do you get onto our Telegram channel? If you don't have a Telegram app, download it. It's like an app, a free of cost app. So you can download it from Google Play Store and App Store, and click on to this link that is available in the description box below. And or else you can just type in JEE_English as well. This link is available in the description box below. And why should you get onto a Telegram channel? Guys, you know what? You will get up to date, in time or before time updates on every class happening on JEE English or any other channel, any other platform that we conduct lectures on. For an example, if you are conducting any lectures on, let's say, on Unacademy learning app, you'll still get the notification if you're on our Telegram app, on our Telegram channel. Okay, so that being said, students, this Sunday from 11 AM to 2 PM, we'll be having a special class on A to Z of capacitors, and this is going to be the part 3. If you haven't covered part 1 and part 2, make sure you are covering it as well, because try to maintain continuity. Anyway, these are like independent topics, but still make sure you're covering each and every part, because something new is being discussed in each and every part. And it's anyway free of cost special class, then all you need to have is Unacademy learning app. So this is on Unacademy learning app. And that being said, we also covered, the complete lecture series around units, dimensions and measurements, A to Z of units, dimensions and measurements in 4 back-to-back sessions, and as well as an extra session on model problems. So do check out everything so that you get a complete understanding, and you know why you should go through units, dimensions and measurements. The easiest chapter and the less time taking chapter would be units and dimensions and measurements, from which you'll definitely get questions in your JEE Mains and JEE Advanced. So that's the beauty of this topic, and you may want to cover this topic on Unacademy learning app. It's all available on Unacademy learning app. So for detailed lectures, you can go through the lectures available on YouTube for different kind of model problems, new model problems, and for extensive sessions, you may want to check it out on Unacademy learning app. And that being said, guys, first of all, download Unacademy learning app. If you don't have one, all you need to do is type in Unacademy on your Google Play Store and App Store, and the first search link is going to be Unacademy learning app. You'll click on that link right away and click on this install button. And you know what, not just you'll get access to those free of cost special classes, but you'll get timely notifications. And not only that, you can attend quizzes, guys, quizzes, free of cost quizzes. And these are like nationwide quizzes where you get access to problems, pre-model problems, like what you can expect in your JEE Mains and JEE Advanced. So do not hesitate to click on that install button. This is one of the most downloaded education apps, so yes, you may want to download it right away. And that being said, guys, if you're looking for champions tool for your JEE Mains and JEE Advanced preparation, we have the best champions tool for you. And what am I talking about? I'm talking about Unacademy subscription, where we have gathered all the best educators across the nation for your JEE Mains and JEE Advanced preparation. Yes, guys, we have the best educators, and you can learn from the best educators and also get your doubts cleared on this platform. Yes, that is true. And not only that, you will undergo a structured program on Unacademy subscription programs. So what do I mean by structured program? You will get access to daily interactive lectures with the best educators across the nation, and not only that, you will also undergo an extensive and intensive program. After each series of lectures, there will be dedicated doubt clearing classes, dedicated quizzes, and more importantly, there is going to be something more and more awesome on it, like national level test series, etc., mega quizzes at the end of each program. So this is something that you want to get. If you can afford it, this is the best thing that you can have for your JEE Mains and JEE Advanced preparation, a complete package. And all you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as a goal. With that, you'll be preparing for both JEE Mains and JEE Advanced, and then click on the get subscription button. That's all you need to do. That is all you need to do, guys. And the beauty is it's one subscription, unlimited access. And that being said, the price is also quite reasonable. It's only going to cost you less than 70 rupees a day if you are going for a 24-month subscription, typically meant for 11th class students, 9th class students, 10th class students. Yes, this is a 2-year-long journey. So this might be the best program that you can choose among Unacademy subscriptions, and you will also get to enroll in the programs based on your preferences. And how do you get to this price point? By applying Murli Live coupon. Do not forget to apply Murli Live coupon. You can get the best discount, guys. Best discount. Avail the best discount on your prices, on your Unacademy subscriptions, by applying Murli Live coupon. And that being said, students, we also have convenient payment modes for you, like pay in parts, which is our in-house Unacademy feature. So this is our in-house Unacademy option, payment option for you, and this lets you split your payment into multiple parts, so that it takes away the burden of paying all the fee at once. We also give you access to the no cost EMI option. You can also choose no cost EMI option. If you don't have access to no cost EMI option, still you can go with our in-house pay in parts option. And using no cost EMI, you don't have to pay any interest. So these are typically the two payment options which takes away the burden of paying all the fee at once. So you may want to check it out while purchasing Unacademy subscription. And students, that being said, if you are in 12th class, and if you're planning to only prepare for 1 year, or if you're a long-term student, or dropout student, so this is the program for you. So what do I mean by this is the program for you? Maybe you want to go with the 12-month subscription. And guys, the cost is also quite reasonable. Again, it's less than 2,900. It comes at a cost of 2,888 only. And how do you get to this price point? By applying Murli Live coupon. So do not forget to apply Murli Live coupon to get the best discount on your subscription purchase. And that being said, students, not only that, absolutely. Sorry, good evening. And yes, we'll soon get started with that topic as well. And that being said, students, this is the best discount that you will avail. Not only that, not just forget the best discount point and etc. We have 7,000 plus materials for your JEE Mains and JEE Advanced preparation, which has all been taught by the best educators across the nation, and 1,000 plus live programs right now going on for your JEE Mains and JEE Advanced preparation. And students, this is the time to get started. This is the time to get started because the programs are hosted in such a way that can lead you to become a champion. So yes, this is a champion's tool. Avail it soon if you don't have one. And that being said, students, if you are already on an Unacademy subscription, do not forget to enroll to my Optics Basics to Advanced course. This is the best course that you can have for your optics. It's a complete course. It's a comprehensive course on optics, in which we'll be covering both ray optics and wave optics. And this too, we are going to undergo full-fledged program, 60 to 70 intensive sessions. So understand, it's going to be anywhere around around 100 plus and odd concepts, and not only 100 odd concepts, will be solving 500 plus model problems, and it has been just launched now. So if you're planning to avail the subscription, avail it soon and enroll to this program. The enrollment is still open. Just go and grab that, just click on that enrollment, so that you can attend this Optics Basics to Advanced coursework, and you can know everything about optics, even from a practical perspective. It's going to be super interesting course. And yes, don't even miss out a single lecture. Maintain the continuity, be it you are on YouTube or be it you are on Unacademy subscription platform. And that being said, right now our team has hosted anywhere around 7 programs on Unacademy Plus right now, just for you, exclusively and completely in English. So that is the beauty of like our Unacademy as well. We deliver content for you in multiple languages. And guys, right now, you know what, we have a program on differential calculus, optics, chemical kinematics and electromagnetism for 2021 aspirants. And if you're 2022 aspirant, you can get complete courses on graphs, sets, relations and function, mechanics and redox and equivalent concepts. So make sure you're attending these courses and you're not missing out even a single lecture. It's going to be super interesting, guys. And we have the best team. Not to say that, like we have IITians and IITians, but we also have head of institutions. So you don't want to even miss out a single lecture on JEE English or Unacademy subscription platform. Make sure you're attending every single lecture. And with that, we are going to get into a very simple concept. So practice, practice and practice makes human perfect. And today's concept requires a little bit of practice. And you can expect some questions around this concept, because this is a very practical concept. It takes a less amount of time. If you know this concept, that itself is good enough to solve a problem within 2 minutes. So you can expect typically these kind of questions, as your examiner or the person who sets your paper knows that you should be able to solve it within 2 minutes. So make sure you're understanding it really well. Here is where your electrostatics is going to become super smooth. And as such, if you have noticed, electrostatics is easy. It's just a bunch of math mixed with concepts, but once you practice, it becomes really easy. So there are very, very different concepts around electrostatics, and today we are going to get into one such thing. We'll get started with a short problem then, and with using all these model problems, we'll be understanding the concept. Okay, so today's session is going to be all about, we are going to deal with infinite geometry, and in fact, we'll be dealing with such geometry for even a little bit more time. And tomorrow we'll be having a strategy session for 2021 preparation. So make sure you're attending it. Don't miss out the strategy session. It's going to be interesting. That being said, guys, let's get started with the question then. Let's not wait anymore. And as you remember, I told you something known as a linear charge density. What is linear charge density? So linear charge density is typically applicable for a line of charge where you don't have this geometrical structure spanning in 2 dimensions or 3 dimensions. So before we get started, let me quickly give you a brief on this concept as well. So there are typically 3 things that you want to understand before we get into this. One would be like linear charge density, generally indicated with lambda. Okay. So linear charge density indicated with lambda. What does this mean? Charge distributed across unit length. So this is charge per unit length. It can be positive, it can be negative. And the next thing is surface charge density, generally indicated with sigma, areal or surface charge density. Whenever you come across such signs, maybe you want to typically read the question once, but still understand maybe it's around areal charge density or surface charge density. So this is what this is going to be. Q by A. I hope you remember in capacitors we did this Q by A thing. If you attended the lectures, and rho appears to be like mechanical density. Okay, we also use rho for volume charge density, or generally also known as just charge density sometimes. Spatial charge density is also another name, sometimes just called as charge density. Okay, units will be given to you typically in exam, I believe, or it will be told it's the per unit area, per unit volume, etc. So this is unit volume. You may want to note it down. Good evening, Divya. Good evening, students. Take down the notes. Do not forget to share the video. Do not forget to like the video. Share it on every single possible social media that you have, because today's lecture is going to be super interesting. And you can typically expect questions like this in your JEE Mains and JEE Advanced. And guys, remember this thing: linear charge density, surface charge density, and volume charge or spatial charge density, sometimes just also denoted as charge density. So why are we discussing this? Probably we'll be solving problems around them in this session. Yes, that is true. Another thing is, maybe you want to match out the dimensional consistency. Right? You want to match out the dimensional consistency. Sometimes you can just do the dimensional consistencies to analyze the answer in your exam. Okay, so this is L to the power t minus 1. Let me do a thing. I'll just choose a different color so that this is clear. So anyway, you know how to derive the dimensions of each one of them. But I don't think that is very important to you. But try to match sometimes, if at all you think there is, don't go for it right away. in your exam. Don't go for it right away. But if you think there is some dimensional inconsistency, maybe your answer can just be derived from dimensional consistency. Why did I do this? I don't know why did I do this. Let me just correct it. This should be let me just quickly correct this, guys. So Q is I into T. This is I into T into L to the power minus 1. What is I? Current, or it can be said as A sometimes, A into T into L to the power minus 2. Okay, something that you want to do if you think there is an inconsistency in the A is not area, A is current. Okay, A is current, okay, L to the power minus 3. You want to do this if you feel there is a dimensional inconsistency in your question. Alright, then let's get into this question then. So there is an infinite length rod with linear charge density lambda, then electric field magnitude at a point P at a perpendicular distance. So notice it's an infinite length rod, or rod of infinite length. Typically in these kind of questions, yes, one of the ways is we have done it earlier. If you remember, how did we do it? We took the angle, etc., and we had charge density, and we said this angle will tend to 90 degrees. This is one of the ways of doing it. But wasn't the time taking? Yes, trust me. Yeah. Or if you remember, it was time taking. It was time taking, guys. Trust me, it was totally time taking. Now what I'm saying is, let's not do all of this thing. If I want to find out the electric field at point P, I simply draw, maybe around any of this point, I'll simply draw a Gaussian surface. So with this, your entire concept around Gaussian surface will also become clear. Don't worry about it. So if you already know the answer, just type it out on the comment box or in the chat box. And if not, I'll just take you to the solution. Given options are K, lambda by L. What is lambda, guys? Linear charge density. Lambda's unit, as we discussed earlier, was I into T, L to the power minus 1. This is Q by L. Okay, and K lambda by L, 2K lambda L by under root of L square by A square, K lambda L divided by under root of L square plus A square. I don't know what is, okay, there is a 2 and K. And the third one is 2K lambda by A. Let's get into the question. I'll tell you the simplest way to solve it. Draw a Gaussian surface. Whenever you have infinite charge, try to draw a cylindrical Gaussian surface. I mean, like a linear charge or a cylindrical surface, you want to draw a cylindrical. What is this? This is a cylindrical Gaussian surface. Now we are drawing the imaginary surface. So if you remember in last lecture, we had the question tell us that was the Gaussian surface, but now we are drawing the Gaussian surface. And trust me, guys, this is super simple. I'll tell you why this is super simple. So if I'm drawing this Gaussian surface and deriving things, it will hardly take me 2 minutes. Okay. Even if I'm telling you the concept and doing it, it's going to take less time. Okay. Anyway, we're just getting started with the concept, and maybe some of you have some of the doubts around this Gaussian surface, what is happening, etc. Okay, first of all, let me explain a few things before we get into this concept. What is the problem? Okay, literally, notice that this is the fastest way to do the thing. Here is surface 1. Surface 1 is this, like this kind of thing. Okay, the circle on the top or the disc on the top. Then there is cylindrical curved area, which is the most important thing. You'll understand why. And there is also one surface on the bottom. You have drawn a cylinder, guys. So there is going to be 1 surface, 2 surface, and the 3 surface. Right? 1 surface, 2 surface, and 3 surface. So there is also 3rd surface. Now the thing is, okay, what about the top and the bottom surface? So we are going to analyze, as you understood, we are going to analyze flux and then derive the electrical field. We need to know what is the value of flux. So one thing you may want to understand generally in these kind of things, it is a linear charge density. Then only this is possible. It's a linear charge density with uniform lambda. Okay, somewhere it should not be divided by half or something like that. Then the entire thing would change. I'll tell you why. So in such cases, Okay, so okay, let me do a thing. Let me just mark these three things. So total flux is what? Amount of flux exiting. It's positive charge, all the flux are going to exit. But do remember, flux, write it down with the apt kind of sign convention. There would be flux 1, use different color, flux due to surface area 1, flux due to surface area 2, which is the curved surface area, and flux due to surface area 3. Now in these three cases, this is also another ring like this. Okay, this is a bottom ring like this. So this is the third one. Now let me tell you something interesting. Just notice what I'm drawing right now. So this many amount of flux through S1. Okay, if this is an infinite charge. Okay, some of you might be having a query. So if it's an infinite charge, why are you drawing like a Gaussian surface that is finite? And you'll be drawing the Gaussian surface at a distance A. Why A? Because we are analyzing at a distance A. We are analyzing at a distance A for the point. Okay. So some of you might be wondering, why am I drawing a finite Gaussian surface? It can be an infinite one as well. Not an issue. But we are analyzing at this point A. So what we are going to do, we could have drawn a circle as well. We could have drawn a thin disk as well. When thin, hollow disk as well, and analyze thin, thick ring, something like that. We're doing the same thing. It's like a thin, thick ring for, an infinitely long space. Now, what is happening is, if this is positive charge, the fields are exiting this way due to all these charges. Notice the direction. Notice the direction, because that is very important when we do the flux calculation. And typically it would also be in this direction, right? There would be something like this. Let me use the same color. Okay, one way of understanding is, since the field would be there like this, like this, like this, field would be exiting from this positive charge. Just nearer you go, you still be exiting with more intensity. Similarly, for the opposite side, it would be exiting. But what is changing? Okay, as it was exiting earlier, similarly, even in this case, it would be exiting. Okay, so one way of understanding is, this is, if this is the perpendicular bisector, if perpendicular bisector lies over here, all the field due to the field along S1 and S3 are cancelled out. There would not be any field. Really simple. So that is one way of thinking about it. Maybe it's not a perpendicular bisector. It still works. Why? It's an infinitely long, like wire, and the field that was exiting through this surface is also the field that is exiting through this surface, even varying with distance. At this distance, maybe they are uniformly exiting on both sides, but as you move over here, and move over here, same amount of fields are exiting, but in the opposite direction. So in a way, I can state something like this. What are we going to say is, I hope you understood that concept. If not, you can type in, guys. I will just back. So what I'm going to say is, the flux that is going to exit in this direction, Fs1, and the flux that is going to exit in this direction are equal, but in opposite direction. Hence, I can just simply cancel out through method of symmetry. Alright. So simply your flux is how much? Just the flux due to surface area 2. Just the curved surface area. Because flux is getting cancelled out. They are in the opposite direction. Due to this, it is in this direction. If you notice, because you would have to ultimately analyze, give one sign to one of the directions. So let's say if I'm observing from this direction, observe that as if the amount of field lines that are, you know, like exiting from this point is also exiting from the other point, the flux is getting cancelled out. Right? And now left over is just surface 3, which is the easiest surface that we can deal with. Why it's so easy? Let's understand. So you understood that point? Now we are only concerned about the surface 2. Now, when we are talking about surface 2, what is the radius of this cylinder? Radius of the cylinder is just A. Simple. What is the surface area? Surface area is going to be, let's say, surface area of SA2. Let me give it as SA2, just SA2. Or just A2 maybe, that helps. A2 is how much? 2 pi r L. Instead of r, I can write it as A. Okay. Let's see why have I done all of this until now. What is the thing behind this? And typically you do this, guys, okay? This is the surface area. Now what I'm saying is, how much is this? I'm just talking about phi s2, which is nothing but phi e, which is nothing but E dot. And how are the fields exiting? Radially in perpendicular direction to the surface. Radially in the perpendicular direction to the surface. Okay. If you do a E dot A, the area vector is going to be something like this, n cap. The field is also exiting. So think about it as, okay, this as that infinitely charged, long rod. Just I'm talking about one cross section, and what is happening now? The fields are exiting in this direction, exiting in this direction, exiting in this direction, exiting in this direction. And how is your area vector? Area vector is also radial. So I can say, sure, Sakshi, we'll do that. Okay, we can say both are in the same direction. So we are going to write it as E into A, EA cos 0, n cap. And if I'm saying R cap is due to the electric field, they both are in the same direction. They both are in the same radial direction along the cylinder. Hence, you'll cancel it out. Absolutely, Sakshi, we'll be doing that. We'll be doing that. Okay, really simple. Really simple, guys. Simple. And how did I get this length L? What is the length L? Length L should have been this, right? Should be of length L. This entire thing should be of length L. How much charge is enclosed in this length L? So you can apply this for infinite as well. You understood that point. Charge enclosed in the length L is nothing but lambda into L, guys. Really simple. That's it. Now what did you do? Just apply Gauss Law. Did you do that? Charge enclosed is how much? Lambda into L. Within this space length L, I'm saying this cylinder is limited of the cross section L. How much is the charge enclosed in it? Lambda into L. Because field is going to be created due to the infinite long thing, but then your cylinder will also become infinitely long. Don't worry about it. And what about area? Area is 2 pi a L. Just as simple as that. 2 pi a L, 2 pi a L. If you have any confusion, circumference into length. That's it. Now let's get into the... How much time would it would really take if you understood this concept to solve this problem? Just think about it. Isn't it the simplest thing that you can do? Yes. Gauss Law really makes our life very simple. That's the beauty of Gauss Law, guys. That's the real beauty of Gauss Law. So we're going to write down Gauss Law. Gauss Law says that flux is equal to Q enclosed by epsilon naught. That's it. How much is Q enclosed and how much is our flux? we are calculating flux for surface area 2, which was because surface area 1, surface area 2 cancelled out. Flux was cancelled out, which is nothing but E into A2. What is E into A2? We don't know E yet. E is in the R cap, we know that thing. But anyway, if direction is given to you in the question, you should take it as E into R. Okay, radial direction, right? Think about the rod in this way, and anyway, towards the point P, it will be like this. Okay, so A2, what is the area? 2 pi AL, right? And what was the charge enclosed? If you remember, charge enclosed, I'm just taking a different color to indicate you what is the charge enclosed. Charge enclosed was nothing but lambda into L. Okay, if I'm talking about charge enclosed by epsilon naught, I believe this is visible, and this is nothing but lambda into L divided by epsilon naught, which is equal to, guys, this L is small l, okay? The same L, both are like, not big L, small l, they are just the L of same length. Right, that's it. That's it, guys, that's it. Cancel out the L and L. There you go, you have the solution. That's it. So this would come out as, just writing down the result over here, and that's going to be lambda by epsilon naught into 2 pi A, right? And yeah, let me do a thing. Let me further write it down then. So this calculation, let's do something very interesting. Electric field is equal to lambda by 2 pi epsilon naught into 1 by A, which I can say 1 by 4 pi epsilon naught is K, and this is nothing but 2 by K by 2, sorry, 2K 2K lambda by A into R cap. That's it. So that's it, guys. This is the result. You were thinking, this was supposed to be, like taking all the lengths, etc., doing that thing. No, Gauss has made our life really simple. Okay. Similarly, you'll notice as we move on to the next problem, and the next and the next problem, next and the next problem, everything is going to be simple because we have access to something known as Gauss Law. Because Gauss Law was actually the entire expression, which is, it looks a little bit complicated. Actually, it's a very small. The entire expression is Gauss Law. If you're totally new to this concept, this is Gauss Law. Gauss Law says flux, electric flux is equal to charge enclosed by epsilon. Yes, that's right. Really simple. Let's move on to the next thing. Alright, so very careful, guys, very careful, students. Try to understand each and everything that we are going to discuss from now on. Okay, the Gauss Law is going to make our life very easy, but how are we applying the Gauss Law and how it all works, you need to understand really well. Charge should be enclosed on it. Okay, now there is an infinitely long metallic cylinder of radius r, and it has uniform surface charge density or surface charge distribution of sigma. Then the electric field magnitude at point P would be how much? At a radial distance d. Okay, from the center. This might be the center of the and given to you, radius is greater than A. It's an infinitely long metallic cylinder. Take a couple of seconds, think about it, and you know what? Just try to come up with the answer. This can be really simple. An infinitely long metallic cylinder having a surface charge density sigma. The point P is away at a distance D. Think about it carefully. I believe then let's get into this question. So it's a metallic cylinder. Where would all the charge reside? On surface. Whatever it's plus or negative, whatever it is. Just I'm taking positive, it can be even negative, etc. Nothing inside. I hope you understood that point. If I'm writing it over here, it's on this cylindrical surface area. Point P is inside the cylinder. What would be the charge enclosed? 0. Because all the charges are residing on the surface. On the surface. Now if I said that all the charges are residing on the surface, then what is happening? Charge enclosed is 0 at some point A. This at a distance D, okay, at a D less than that of R. Q enclosed always 0 for metallic cylinder. Metallic cylinder or any conductor, perfect conductor cylinder, okay. Then what is flux? Flux is also 0. Because flux is basically from Gauss Law, Q enclosed by epsilon naught, which is 0 by epsilon naught, which is 0 again. Flux is 0, we know area is not 0. Hence, E dot A is not 0. You know that thing. What should be 0? Hence, area is not 0. Electric field is. The answer should be 0. Right? Okay. Using this concept, you can expect a question, students. So carefully try to understand the concept. This is the easiest part of electrostatics that you can deal with. Trust me, there's nothing easier than Gauss Law, because a two-step calculation. Literally, it's a two-step. And in the earlier one, it was a zero-step calculation. Understood? Right? Let's get into the next question then. But try to learn the concepts as we move into that, and everything. Try to analyze everything around whatever we are doing in Gauss Law. Maybe you want to, think about different scenarios. Maybe take it as, like a plastic cylinder or an insulator-based cylinder, and also try working around maybe like graph-based problems, etc. Okay. This alone does not complete everything. So an infinitely long metallic cylinder of radius r has uniform charge density as in the earlier case. So this guy has uniform charge density sigma. Okay, and the radius is r. Now find the field at a point P where the radial distance from this point away from the center, how much? It is less than a. Okay, R is less than A, R is less than D. Okay, that means D is greater than A. So, okay, correct this point. D should not be A, I think earlier one. So this is R is greater than D. That's greater. Okay, for any R greater than D or R greater than D, you get this. For metallic cylinders. Okay, let's get started with the problem then, and I believe this is a very easy problem. Again, tell you why. All you need to do is draw a Gaussian surface. I'm going to draw a Gaussian surface, and this time the Gaussian surface is going to be, this time charge enclosed is not 0. You know that charge enclosed is something finite. So maybe infinite. Yeah. I guess this is how we are going to work on. So what I'm going to do is I'm going to draw like a cylinder of radius d, a Gaussian surface cylinder of radius d. Okay. Right, I think simple, but let me just now Gaussian surface. So this is going to be of radius t. The radius looks like greater than d, but it's only t. Okay, and so finite. So finite, we will initially take everything of finite length, then we'll say if this was even infinite length, this is okay. Gaussian surface is an imaginary surface that we are drawing right now to make things easy. Alright, so if this is of length L, what is the surface area of the cylinder enclosed, this metallic cylinder with charge distribution? Metallic cylinder with some charge distribution. How much is the charge distribution? Sigma. What is the charge enclosed? This areal charge density or surface charge density, right? Charge enclosed is the first thing that you'll write down every time, because half the time you'll come to know about the solution if you write down the charge enclosed and identifying the right kind of Gaussian surface. So this should be sigma into 2 pi r or d. It should be r. Because charge is not available on this imaginary Gaussian surface. The charge is only available on the cylinder that exists, not the imaginary Gaussian surface that you are drawing. Into length L. This is a capital L, so we'll write it down as a capital L. Okay. That's it. We need to do anything more, but we need to also write down one more thing, that is the surface area of this cylinder, which is quite easy again. What is the surface area of this imaginary cylinder, guys? Its area of this cylinder is 2 pi, radius is how much? D. Radius is D, length is L, finite length L. That's it, guys, that's it. Now apply Gauss law. That's it. That's all you need to do. Literally, that's all you need to do. Flux is equal to Q by epsilon naught is equal to, flux is what? E dot A. And what about E? So it's an infinitely long cylinder, just like the earlier linear charge distribution. It's just a cylinder. Again, no flux will be exiting on the lower and the upper surface. But net flux will not be exiting. Okay. Hi Ashok. Hi. So flux is not going to exit on the upper and the lower surface. So I'm going to say due to the upper surface, lower surface, just like the earlier case for the imaginary cylinder, this S3 and S2 cancel out, only 5S2 would be remaining. So this is easier than earlier one. As you move into the chapter, you will realize everything is very easy. So this is how much area is, this is what? This is the area of, let me just check it out here. Okay. Choose a different color. This is not the area of your cylinder, your real cylinder that exists. This is the area of this imaginary cylinder that we are drawing. Right? Imaginary cylinder. You are right. And what is charge enclosed? Charge enclosed is, okay, now if you understood, this was all like 2 minutes, 2 minutes, 2 minutes, 2 minutes problem. Once you understood Gauss law, so sigma into 2 pi, I'm sorry, it's not A, let me correct this, R into how much? L, some finite L, within this length L, how much is being enclosed? That's what we are calculating. Divided by epsilon naught is equal to E into, I'm writing down this as 2 pi D into L. 2 pi L cancels out. 2 pi L cancels out. What is left over? Left over is electric field. Again in r cap direction. Okay. Let's first write down the magnitude. So magnitude of electric field or electric field intensity is how much? Epsilon r sigma r epsilon naught d. Okay, if I'm putting a vectorial sign on the top little arrow, change it to r cap. That's it. We'll add a r cap. That's it. Simple. Every, like, you know, but there are a few things to understand. I'll tell you what it is. So the answer should have been, D should be on the bottom. Okay. Way of, but you don't have to, you know, memorize this. This is like, you know, you can derive it even within like 30 seconds if you understood the concept. But there are a few things that we need to understand as we move into this. What did we see? I'm going to draw a graph for electric field versus radial distance r. I'm plotting r over here, electric field over here. So one expression we got is for this radial distance should be d. In this case, in our case, it is d. It's not r. It's t. For varying distance t. So we have got two equations until now, if you remember. So this is also, we are going on the concept side by side. So one is we got electric field as 0 for any r greater than d or d less than r. If the point is inside the cylinder, I'm not talking about specifically about this problem, just a general concept. If the point is inside the cylinder, all the charge resides on the surface, as you know. Hence, there would not be any charge enclosed, hence electric field is 0. The charge, if r is greater than, if r is less than d, we had an expression like this. We just derived it, sigma r into divided by epsilon naught divided by d. Okay, so it's a 1 by d graph because sigma epsilon r is constant. You can assume this to be like something like this. Let me come to this point. This is when r is less than d. So this can be equivalent, be written as something like this. Okay, when d is equal to r sigma by epsilon, but we are not going to get into that thing. That would be the maximum field, isn't it? So if I'm talking about maximum field, it's sigma by epsilon. But suppose that always d is greater than r. Just at d is equal to r, just on the surface, you will have the maximum field. Where would you have the maximum field? Maximum field, not on the surface, but maximum field would be on the surface. Right? Not on the top surface. This is where you will have maximum field, and what is the value? Sigma by epsilon. Right? So yes, if I'm talking about electric field, this can be written, but if you notice this three terms, that is this sigma by epsilon naught into r, which is radius of cylinder, which is fixed, right? Radius of cylinder is fixed. So I'm talking about these three terms, they are sort of constant. They're constant, like not sort of constant, but they are constant. So you can write something like C divided by K. So you need a 1 by y is equal to 1 by x. 0 until where? So electric field would be 0 until the point R. Okay, R is what? Radius of the cylinder. You can notice the R over here. R is radius of cylinder. Radius of which cylinder? Metallic cylinder or metal cylinder or conductor? So this is for just E versus D graph. I'll say Y. E versus D graph for conductors. Let's call it as conductors. Okay, or any metal. Now let's draw the graph. What it is, y is equal to 1 by x graph is what we need. Look something like this, but not deep like. So this is 1 by d. So this is like y is equal to 1 by x graph. Okay. You can write it down as y is equal to 1 by x graph. So this is how your electric field would look like. Right, electric field versus distance away from the cylinder. You can call this as electric field intensity rather. And this is distance away from. Where do you have the maximum? Maximum is at the cylindrical surface. At the cylindrical surface, you would have the maximum field. How much is that? It is going to be sigma by epsilon naught. So this value is how much? Sigma by epsilon. We have this, hence the analysis is complete. There is this just right. Means you know radius R is of cylinder. That's it. You can note it down, take a screenshot. It's a very important concept. And in electrostatics, you typically get questions even around graph. You would identify the difference between 1 by x graph and 1 by x square graph. Okay, how quickly the y is varying, how steep is your y varying with x. Okay, 1 by x graph would typically be more sensitive. 1 by x square graph would be more sensitive than 1 by x graph. Hope I said that 1 by x square graph would be more sensitive than 1 by x. Alright, I think this concept is clear. Let's move on to the next thing then. Right. So now let's get into a very interesting. Now this question is going to become even more intensive and interesting, but still will remain simple. Okay, this entire lecture is going to be simple, guys. An infinitely long plastic cylinder of radius r. Notice that it's an infinitely long plastic cylinder of radius r as a uniform spatial charge density or space charge density of how much? Of rho. So what is it? It's something like this is spatial charge density, which is q by volume, whose, I'm going to write down the dimensional formula. This is going to be something like m to the power 0 anyway. This I T L to the power minus 3. Alright, so that is it. So let's get into this thing and get started on this. Okay, that's all. Alright. Now the thing is, I need to analyze the electric field at a point D. At a point D, which is how much distance away? D distance away, but inside the cylinder at a radial distance D, where R is greater than D. This can be written something like this: R is greater than D. So if R is greater than D, if it's an insulator, do you think the electric field is going to be 0 just like in the earlier case? Just like in the earlier case, do you think the electric field is going to become 0? I don't think so. Why? So it's an insulator and there would be charge even inside. Even at this point, there would be some charge. It's an insulator, right? So you draw your Gaussian surface inside. It's an infinitely long thing, so I'm going to draw a finite circle, finite cylinder first. This is my Gaussian surface. What I'm saying is, now the charges would also exist not just on the surface but inside the surface. Same thing we have to do, don't worry. But now what have we got? There is some charge enclosed. No more, since it's an insulator. In our case, this is plastic. There would not be a charge enclosed is equal to 0, but there would be some charge inside it. So there would not be a charge enclosed is equal to 0. So charge enclosed is not equal to 0. Okay, so you need to understand this. Metal, all the charges are residing on this. Very important concept. Very important concept. Very. Many times questions just come around this concept. You understood this really well. This is a basic thing, right? But if you understood this really well, you can answer many questions in your JEE Advanced as well within few minutes. I'm not just talking about Gauss Law, I'm just talking about insulator having some charge distributed all along its volume. Charge can be distributed along volume. That is it guys, that is it. Now the question is no more mystery. I'm going to call this of length L. What is the charge enclosed in this case? So the charge density, spatial charge density or the volume charge density is given as rho. What is the amount of charge enclosed within this imaginary cylinder of radius d? Okay, this entire thing, let me just do a thing. Let's redraw this, surface. Just want to make it a little clearer. You understood that point. The charge is residing all inside it. Let's do a thing. Let's redraw the surface. So this is a surface. This is what a Gaussian. Of how much? Radius is equal to d. This is our imaginary Gaussian surface. Why are we drawing this imaginary Gaussian surface? To calculate electric field. What is this Gaussian surface? Cylindrical Gaussian. Gaussian surface is having only surface area. But charge enclosed is all about volume as well. So how much charge is enclosed? I'm saying is how much charge is enclosed within the D. Again, it's a 2 minutes, not even 2 minutes, guys. It's like 1 minute problem, I guess. Charge enclosed is within the distance d is how much? It's going to be rho into what is the volume present inside this cylinder D. We are worried about cylinder D because your charge is lying within the cylinder D only. We are not concerned about the charge outside. We are only concerned about these all charges does not matter. They don't create any impact. We are only concerned about the charge that is available inside this Gaussian cylinder on a red color. Okay. Now this is how much rho into charge density into volume. How much is the volume? Can I say this is 2 pi d, or sorry, pi d square. Pi d square is the surface area into, what is the finite length? Let's give it a length. It's going to be like, you know, L. So this would be pi d square. I think let's keep it as capital L. Okay, really simple, guys. That's it. So today we are going to deal with this kind of concepts, and you will trust me, you'll realize that this could have been the easiest thing. If at all you missed it, you'd regret, and if you get this in exam especially, you'll regret. Okay, so this is the charge enclosed. Okay, that is it. Now we know what is charge enclosed. What we need to do, find out something known as the volume, right? Pi d square into L. Surface area of that cylinder, like this part of the cylinder, into L. Now, what is the Gaussian surface area? Gaussian surface area is how much? 2 pi d to L. That's it. Write down the Gauss law. That is all needs to be done. Most of you must have already analyzed the answer and probably guessing out the answer as well. You can type it out. So Gauss law says that electric flux is equal to charge enclosed by epsilon naught. And how much this would be? This would be electric field into area. Radial direction, area, radial direction, so E into A. And how much is field, guys? Sorry, how much is area? 2 pi d into A. Okay, let's write it down in the next line. Not extend this anymore. Okay, I'm going to write down those two things that we found out. One was charge enclosed, which was how much? Which was rho into pi d square into L. And remember, this length was L, that's why we got it. We took a finite length. It's ultimately an infinite surface, but now we have area as 2 pi d into L. Right, pi gets cancelled out, 1d gets cancelled out, LL gets cancelled out. What is left over? Electric field is simply this thing divided by 2. That's it. The leftover thing on the other side, pi d divided by 2 epsilon naught. Okay, pi also gets cancelled out, right? Where did we get this? Basically, very, very simple expression. Just very similar to last one, but let's, before graphing out things, let's simplify a few things. I'm going to be saying that just for the sake of convenience. Okay, when would be the electric field be about something? So maintaining the dimensional consistency. Yes, we are maintaining the dimensional consistency. Field would keep increasing. Okay, let's not go to that now, because until and unless we don't take up the other case, we won't understand it. Let's keep it as this thing for now. With distance d, electric field is increasing. As d increases, this can be r cap. Okay, the distance d increases as we are moving away from the cylinder inside the cylinder. Think about it carefully. Inside the cylinder, what is happening? Your electric field is increasing. What should be the answer? It should be rho into d by epsilon. Little counterintuitive, or rather it is intuitive. It's intuitive. Why? Charge enclosed is increasing. It's an insulator. Okay, so hence this is fine. This is not counterintuitive. Okay. From Gauss law, this is not at all counterintuitive. As counterintuitive. If only charge resided on the surface, then it would have been a little counterintuitive because everything is going to be zero. Okay, I believe this was simple. So let's do a thing then. I will derive the other case as well. We don't have a problem on that. So what if it was lying outside? So this was when, you know what, this is only true when R is greater than D. If I am talking about a case where D is greater than R or R is less than D, R is the radius of the cylinder, right? Then in this case, things would change. Do remember. So let's solve for this case because we have spatial charge density, but same thing you will get, guys, as you got earlier, right? You'll get the same thing. Let's assume an imaginary Gaussian surface like this, and let's say instead of this diagram, what we have is like, you know, the distance D has been extended up until here. Forget this older D. Now your distance D has been extended up until here. We'll directly write down few things. So this is the case. Okay, let's give it as case 2. Okay, now what I'm saying is let's write down few things before we get into graphing. First of all, charge enclosed is how much? Quickly, guys, is how much it's going to be. If this is of length L, it's going to be the entire thing, guys, into L. I mean, like infinitely speaking, it's entire thing, but since it is limited by L, it's just going to be divided that by L. Okay, so anyway, so in this case it is going to be rho into what is the volume of the cylinder, the spatial charge density, or it's like, you know, volume charge density. It's going to be pi r square into that finite length L. Now only finite is being enclosed. What about your Gaussian surface? Your Gaussian surface is how big is your Gaussian surface? How what is the surface area of your Gaussian surface? The Gaussian surface is 2 pi d into L. Now write down the equation. That is all it requires. Okay, so your Gauss law says flux is equal to charge enclosed by epsilon naught. And how much is this, guys? This is electric field into area. So guys, again, radial direction, E dot A, EA. Okay, so let's write it down. And the next thing we should be solving it because we're running out of space. So this is for R less than T. Now you would get something like rho into pi r square into L divided by epsilon naught is equal to electric field into area, which is going to be 2 pi d into L. LL gets cancelled out. If you noticed a very interesting thing, what is the maximum field? From both the expression you will get this, and pi gets cancelled out. What do we have? Electric field is equal to something like pi r square divided by 2 epsilon naught d. You have again 1 by x graph. So we have two cases now. This case is for r less than d or d greater than r is for apt of having, since this is the distance from so we are measuring the electric field at d. Now what is the difference? And one more thing, what is electric field maximum? Electric field maximum is going to be when r is equal to d on the surface again. Okay, on the surface you are going to have max field. On the surface you are going to have max field. And how much is that? Substitute simply r is equal to d, and in the earlier case we got that by 2 epsilon. But that d was different, guys. Okay, this is this is epsilon. Substitute d is equal to r. I'm really sorry. Substitute d is equal to r. Don't substitute r is equal to d, but substitute d is equal to r. Okay, because R is not varying, D is varying. Okay, that's it. This is the max field. Now, that being said, even in that case, only up until R it is valid, right? So let's do a thing. Let's write down both the cases and analyze the things carefully. So two cases we have when R is greater than D. When the radius of the cylinder is greater than D, we observe that electric field was done something like this. Electric field is equal to rho into T. Not really dependent upon the radius of the cylinder by 2 epsilon naught. Is that what we have? That's what we have. Into r cap. Again, we need to write an r cap over here as well. R cap because it's all in r cap direction. Okay, and what am I going to say? I'm going to say something like this. I'm going to say that this is just a constant. This is something like C into D. Y is equal to x graph, isn't it? Yes. Now next, what we have? We have something like D greater than R. This distance of this point somewhere lying outside the cylinder. So at this point D greater than R, I'm going to say electric field is how much? Pi R square divided by 2 epsilon naught D. You can just simply do some things like think from the Gaussian law perspective. Quite easy. So what is constant in this case? This entire thing is constant, isn't it? So C by, I'll rather write it down as this bracket looks like a function, C into D. The C by D. Okay, so just raising it down, not to confuse you. Anyway, let's keep it up. Let's keep this up because this is also going to be helpful. So yes, let's draw the graph now. Thing that we have been waiting for. Let's take up maybe like case we will do something like this. Coming out this. First of all, I'm drawing out the axis, guys, and okay, right. Where are we going to assign the electric field? Over here. Where am I going to assign the distance from cylinder? Distance from cylinder. From which kind of graph is this? For which this is valid? So 0 electric field is just 0. And it increases linearly up until certain point. What is that point? D is equal to R, which is radius of this cylinder. And then what happens? Isn't it increasing? Electric field is increasing, right? With distance D. The distance D, electric field is increasing. Reaches a maximum. And what is the value of the maximum? Simply substitute anywhere, D is equal to R. So this should be epsilon naught R. Should be rho into R divided by 2 epsilon naught. Is that it? Yeah. So here it reached the maximum, and then again it's 1 by x graph. They give you a bunch of graphs and ask you whether this for insulator or metal. How do you identify this? You would typically use this method. Okay, this is y is equal to 1 by x graph, right? And here it is sigma r square by 2 epsilon naught, and there you remember what it was. So both of them are going to be the same. It's going to be C by D. There also it's going to be sigma r square, not sigma r square, but anyway that's rho r square into 2 by epsilon naught. There it was sigma into r, but if you match all the dimensions, it's going to be the same. Since it's volume, it's going to contain more charges. You can say that way. Maybe if only plus q is distributed along that. so it does not matter. Charge, this side of the graph would look similar, but what are we talking about in this case? We are talking about discussing which part? This is for insulators only. For insulators. Simple, guys. Really simple. I told you. I mean, like, this graph is also simple. The entire thing is simple. If you understood it, good. If you didn't understand it, do watch it again, and do share the video. Do like the video. Do not forget to do that. That's, because it's a very interesting class, and someone in need may also get access to this lecture. So do share this video, and it's a complete video on electrostatics. So do not forget to share the video. And make sure you are understanding everything from now on. If you didn't understand anything until now, make sure you're completing the lectures, because it's very important that you complete every single lecture on time, especially because it's electrostatics. So make sure you are completing the lectures on time. If not, guys, you will be creating a huge backlog in current and electricity, electrostatics, I mean the electricity and magnetism part, or even mechanics. So make sure you are running on the schedule, and that is also true for optics. If you're already on Unacademy Plus, do enroll to this course. We have just launched the course. We haven't even entered the refraction part. So simply enroll to this course and get on to this course. It's an optics basics to advanced coursework on subscription platform course, and it's an optics comprehensive course where we'll be covering both ray optics and wave optics. So a single course where you'll be getting access to both kind of information, whether it should be a wave optic or a ray optic analysis. So make sure you're enrolling to the course. If you're already on Plus, and if you're planning to purchase the subscription soon and enroll to this course, because guys, this is the time to get started. Programs are planned around your exam, so make sure you're purchasing a subscription now if you're purchasing the subscription. That being said, do not forget to share this video, and guys, this Sunday from 11 a.m. to 2 p.m. we'll be conducting the third part of capacitors. So this is going to be a very interesting part on capacitors. It's an A to Z series. We have already covered 2 parts. If you haven't covered that yet, please do cover it. It's a part of electricity and magnetism, and make sure you're maintaining the completeness in each and every topic, be it on optics or be it even on electromagnetism, etc. Any topic, even optics, don't do half and half, because if you do half and half, you're missing out a lot of things, guys. Make sure you're maintaining completeness, and this is a free of cost class again. So yes, guys, this is a free special class on Unacademy Learning app, and you may want to attend it. And that being said, do not forget to share this video, do not forget to like this video, do not forget to click on that bell notification and subscribe button so that you can get timely updates. And yes, do share it on all the social media that you have, because one, you're able to be brainstorm these concepts with your friends and understand it better, and maybe you want to watch sometimes along with your friends. So yes, do share it and discuss, and not only that, do share it on social media, because someone in need may get access to this awesome lectures. It's quite easy. Gauss Law is the easiest part, guys. Trust me, among the electrostatics, this is going to be the easiest part you're going to deal with. So do not hesitate to maintain the continuity. Continuity is very, very, very important. Continuity is very important when it comes to current, electricity and mechanics. Trust me, because each topic will be dependent on each other. For an example, current and electricity is going to be totally independent, or sometimes capacitor is going to be totally independent of each other topic. But maintaining completeness also means you're going to score in your exam. Because from anywhere around those topics, questions can be asked. And keep smiling. Do not forget to smile. Work hard, not only hard but also smart to achieve your success. So work hard and smart, acquire knowledge and share it, kill your ego. And that being said, guys, if you don't have a Telegram app yet, download it and click on to this link. More importantly, it's available in the description box below, and you can also type in JEE_English to find us on Telegram channel. So this is our Telegram channel where we keep you updated before time on all the lectures we deliver on YouTube or Unacademy Learning app. And you may want to definitely get on to this. And that being said, students, we have covered units, dimensions and measurements, the complete thing on Unacademy Learning app from 19th September to 22nd September with an extra session on the following Sunday, so that you get a complete understanding of it. And it's quite easy. It's very simple, and not only that, it takes less time. So think about it, 10% to 8% of your paper within these many hours. That is possible if you cover units, dimensions, and measurements. Do not forget to do this even if you're 2021 aspirant, and typically you get questions in your JEE Mains and JEE Advanced. Definitely, generally, definitely is something that you can say. Every year you would see a question from units, dimensions, and measurements, definitely in JEE Mains, and even definitely generally in JEE Advanced. And it's all available on Unacademy Learning app. So these kind of lectures with different kind of model problems and different kind of concepts are available on Unacademy Learning app. So do not forget to watch those videos, and do not forget to download the Unacademy Learning app. All you need to do is type in Unacademy on your Google Play Store and App Store, and the first search result is going to be Unacademy Learning app, the most downloaded learning app. And guys, let me tell you, once you click onto this link, you may want to click onto the install button, because we are impacting near about 7 million lives a day. So definitely click on that install button, and not just for the kind of information that you would get on Unacademy Learning app, but once you follow your educator, you'll also get live notifications. And not only that, guys, the amazing thing about Unacademy Learning app is it also gives you access to features like quizzes, where you can attend model problems like the one that you would expect in your JEE Mains and JEE Advanced. So again, a free of cost thing. Again, do not forget, JEE English is a free of cost initiative in Academy. So do share this channel, do like this video, and do not forget to click on that share button and subscribe button and bell notification. And that being said, students, if you're looking for a champions tool for your JEE preparation, for your JEE Mains and JEE Advanced preparation, we have the best one for you. And what it all comes along with, it comes with the best educators across the nation. And you can get your doubts cleared from them, not only attending daily interactive classes, but also you can get your doubts cleared from them. So apart from that, you will be undergoing a full-fledged, extensive and intensive course. So you will be attending daily interactive sessions. Along with that, you will get access to doubt clearing sessions where you can get amazing doubts. Yes, today was actually a doubt clearing session, and we had amazing doubts on our optics chapter. That was quite interesting, and you may also want to do that, because it's also about maintaining the timing, getting your doubts clear, maintaining the completeness. Everything is available in a very structured way on Unacademy subscription. So yes, guys, it's also about doubt clearing sessions, and you also attend quizzes, national level test series, everything in a single place, a complete package with the state-of-the-art technology. What do I mean by state-of-the-art technology? You will get experience of JEE Mains and JEE Advanced exam. Like, the sort of the environment that you experience on Unacademy subscription platform is going to be the same that you can expect in an exam. All you need to do is click on that left hand top corner extension bar, choose plus, and choose IIT JEE as your goal, and then you'll click on the get subscription button. And let me tell you, students, another amazing thing about this Unacademy subscription is it's one subscription and unlimited access. And that being said, guys, if you are in 9th class, 10th class, or 11th class, you may want to go for 24-month subscription, which is going to cost you only 2,100 per day, less than 70 rupees, guys. Less than 70 rupees is what it is going to cost you. And anyway, it's a 2-year-long journey, and you do not want to forget to apply Murlidharan coupon to avail the best discount on your subscription purchase. This is how you'll get the best discount, so do not forget to apply the coupon. And that being said, guys, we also have convenient payment modes for you, and we have something known as pay in parts or in-house feature, which gives you the ease of splitting your payment into multiple parts without going through the burden of paying all the fee at once. And not only that, guys, we also have no cost EMI option, which is something that you may want to check it out. And this also takes away the burden of paying all the fee at once. Yes, definitely these are the two options that you may want to check out. We also have other traditional payment modes like debit card, credit card. These are like two payment options that can reduce the hassle, or take away from you from the hassle of paying all the fee at once. And guys, that being said, if you are looking for 12-month subscription, and when would you do that? Typically whenever you're in a dropout student, or you're in long term, So you would be taking up 12 months subscription, or if you're in 12th class and planning to only prepare for 1 year, this is the package to go for, this is the program to go for. And guys, let me tell you, it's very economical, less than 2,900, only 2,888 one. Yes, that being said, do not forget to apply Murli Live coupon to get the best discount on your subscription purchase. To get to this price point, you may want to apply Murli Live coupon, and to get the best discount, apply Murli Live coupon. And students, do not forget that we have 6,000 plus programs for your JEE preparation, and more than 1,000 plus programs going on. It is the time to get started, students. It is literally the time to get started. Hi Rajendra Singh. Hi. Yes, why this is the time to get started? Because the programs are planned around your exam. You want to enroll in the correct kind of exam, program, and do not forget that you must be enrolling to the right kind of program, not to any random program. And we have the best programs for you. So make sure you are attending the program sincerely. You're maintaining the completeness. What do I mean by any program? Maybe it's meant for dropper, and you're in a 2022 aspirant and applying for the dropper batch, or attending the dropper batch, etc. Maybe you're 2022, you may want to check out 2021 lectures, but at the same time, do not forget that you have 2 years to prepare patiently. Maybe you can attend 2021 lectures along with 2022 lectures and get everything completed on time. But maybe not, sometimes the things that are not relevant to you. But we have everything for you on one platform, that is going to be our Unacademy subscription. Hello Rajendra, good evening. And students, do not forget to share the video, do not forget to like the video, do not forget to click on that bell notification button and subscribe button. See you in the next